Okay, so for this lesson, we're going to talk about radical expressions. It's the first lesson, 7.1, under chapter 7, which covers roots, radicals, and root functions. The objectives we're going to cover are find roots of numbers, find principal roots, find nth roots of nth powers, and use a calculator to find roots. So for objective 1 here, we have to find the root of a number. So it says, recall that 6 squared equals 36. We say that 6 squares equals 36. The opposite or inverse of squaring a number is taking its square root. So the square root symbol here, we know that it has a small little 2. It's just understood to be there because we write it in for all other roots. For example, cubed root has a little 3 and fourth roots and so on. So for the square root, we just don't write the little 2, mostly because we end up using the square root the most. If you take a look here, we have what is called the index, which is that little number inside the radical symbol. We have the radicand, which is the what is underneath the radical symbol, and the whole thing altogether is called the radical. Okay. All right, so let's work these examples. So the question you kind of want to ask yourself is, what really helps us out? So if we are looking for the cubed root of 1,000, you could ask yourself, what number cubed will give you 1,000? Okay. So in other words, what number times itself 3 times will give you 1,000? And that number is 10. Okay. If you couldn't get there without a calculator, you can also put it in the calculator. Remember, you can put it in the calculator either using the 3 and then hit the math button. And then under the math button, you should be able to find a button that looks something either like this, or it could have the X further out front. And then you would put in your 1,000 afterwards and then hit enter. Okay. The other way you can do it is you could do a parenthesis set, 1,000 parenthesis exponent 1/3, and then enter. And either way should lead you to 10. Okay. We're now looking at the fourth root of 625. And what I'm actually going to show you here is how to do this in the calculator. All right. So we're looking for the fourth root of 625. So I'm going to hit a 4 because I know this calculator already needs to use the math option. And here calculates the fourth root. And I'm going to do 625 and enter. And my answer is 5. You can see it over here to the right-hand side. Okay, so my answer here is actually 5. Fourth root of 150 or 1/256. I can actually, and you're going to see a little bit later, we already saw in class that we can split this due to the quotient rule. So we know that 1 times itself 4 times is 1. It's going to be 1 over something, and that something happens to be 4. So we'll end up with 1/4. And the last question you have to ask yourself is, what times itself 3 times will get you 27? And the reason why I say 27 is because then we can just use that knowledge to get us the 0.0027, or if we really wanted to, we could come back into the calculator we could clear it and we could say, well, what is the cubed root? Oh, this one actually already has cubed, so we can go back and clear it again and go to math and find the cubed root of 2. Nope. Where's my back button? 0.0027. What? That's unique. Hmm. Oh, that one was really weird. There it is. Nope. Okay, sorry guys. I had to pause the video to double check some things. I typed in the problem initially wrong. It is not 2 zeros after the decimal point, is only 1 0. So we were correct with the 0.3 as the solution back here. See, we can see my mistake right here is I used 2 zeros there. That is incorrect. It is just 1 0. And the answer then is 0.03. All right. Oh, sorry, just one point. Okay. Regardless, knowing that 3 is 27 cubed definitely helps you get to this answer. All right. Now that that little bit is out of the way. Okay, let's take a look at what this is telling us. Make it a little bit smaller so we can see the whole thing. All right, find principal roots. If n is even, positive numbers have 2 nth roots. For example, both 4 and -4 are square roots of 16, and 2 and -2 are fourth roots of 16. For a greater than 0, the square root of a represents the positive root called the principal root, and the negative square root of a represents the negative root. For all n, where the square root of 0 equals 0. All right. Nth root cases. If case 1, if n is even and a is positive or 0, then we will use the principal nth root of a. And if negative a square root of a represents a negative root nth root of a. In case 2, n is even and a is negative, then the square root of a is not a real number. Sorry. In case 3, if n is odd, then there's exactly one real nth root, and that is written as the square root of a. If n is even in case 1, then the 2 nth roots of a are often written together as a plus or minus, positive or negative. Okay, so let's take a look at some of those. So here for a, negative square root of 25. So if we come back to what we were told, we are looking for n is even A is positive. So then in the case of 1, we write it together. So we normally would want to write plus or minus 5, but we have a negative on the outside. So I believe they would want that more so than the other answer. Honestly, I would take either, but I would try the -5 first. 4th root, -625. We have an even index, so we cannot have a negative under the radical. So this is not a real number. Now, in this case, it's a little bit different. We have a negative index, so we're allowed a negative under the radical. The 5th root of -32 is actually 2 to the 5th power. So that's going to give us -2 as our answer there. And here we have a negative on the outside, cubed root of 64. The cubed root of 64 is actually 4 cubed, so -4. This is A is the only example here that I would be a little hesitant to not use the plus or minus. All right, let's read this one. Okay, find the nth root of nth powers. Consider the expression the square root of a squared. At first glance, we might think that this is equivalent to a. However, it is not necessarily true. For example, consider the following. If a equals 6, then the square root of a squared equals 6 squared, which equals the square root of 36, which is 6. If a equals the -6, then the square root of a squared equals also the square root of 36. So instead of -6, we get 6, the absolute value of -6. The symbol square root of a squared represents the non-negative square root. So we express the square root of a squared with absolute value bars because a may be negative. So basically, this is them taking out the idea of the plus or minus. Okay, so for here, they want us to do the absolute value of 11. So that gives us 11. Now, again, on the handwritten test, if you gave me plus or minus 11 here, I'm probably not marking it wrong. Just gonna let you know that I probably would not mark it wrong. Now, this one is a little different. This one you would want to do the -11. So 11. Right? Right. Again, I would understand doing the plus or minus, but they don't want you to do it. So z squared is going to be the absolute value of z. And the same for d. If n is an even positive integer, then the nth root of a to the n is the absolute value of a. If n is an odd positive integer, then the square root of the nth root of a to the n is just a. That is, use the absolute value symbol when n is even. So if n is even, we're using the absolute value. So in this case, for a, n is even. And not only that, but we'll also learn that when you have the roots being the same as the index and the exponents being the same, we can kind of cancel them out because we can rewrite this as and when you have 8 over 8 is the same as 1. So we would just do the absolute value of -2. So our answer here is 2. Here we have odd integer or odd index and exponent. So we could go straight to -9 to the 3 over 3, which is just actually -9 because we are dealing with an odd set. Here we would do the negative of the absolute value of -10, which is still going to give us a -10 out. Okay, nearly done. We have an odd index, so we would just do, we would take it to exponent form and reduce it. Whereas with the next one, we have an even index, so we'll still take it to exponent form and reduce it, but then we have to throw it in absolute values. Okay. All right. Last objective is using a calculator to find roots. While some numbers, such as the square root of 9 and the cubed root of -8, are rational radicals, are often irrational numbers. To find such approximations of such radicals, we usually use a calculator. For example, the square root of 15 is approximately this decimal. And then we have the cubed root of 10 and the fourth root of 2. Where the symbol that looks like a kind of like squiggly equal sign is read to be is read as approximately equal to. In this text, we often show approximations rounded to 3 decimal places. So here they give them to you again. Figure 5 shows how the preceding approximations are displayed on either a TI-83 or an 84 plus C calculator. In figure 5A, 8 or 9 decimal places are shown, while in figure B, the number of decimal places is fixed at 3. So you can change those actually in your settings. And I would leave them alone and just round. There's a simple way to check that the calculator approximation is in the ballpark. For example, because 16 is a little larger than 15, the square root of 16 is 4, should be a little larger than the square root of 15, which 3.873 is a reasonable approximation for the square root of 15. Okay, so I will show you these ones in the calculator, and then we'll come back and I'll write them down. So let's clear this, clear all that. The first one is the square root. Okay, must be under here. Nope, weird. Oh, there it is. It's up here in blue. So second square root, and then it's 73. Okay, so you can see that's 8.544. We then want to do the negative. Oh, enter that one. We then want to do negative second square root of 92. And that's negative 9.592 if you round up. We then want to do the fourth root of 92 again. So that's 3.97. And then the fifth root of 33, which is 2.012. Okay, so those are all there. You can just go ahead and come straight here. And you can say used calculator. Okay. All right. And then the application-based problem for this class or for this section deals with plugging in L and C, and F here is in cycles per second. That was missing. L and C are both written in scientific notation. Okay. So I would rewrite them. I would do L equal to 0.12345 and C equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we just have to plug them in. So F is equal to 1 over 2 pi times the square root of L times C. 6, 7, 8. And then I can show you the steps on the calculator that I would take. So let me clear all of this. So the first thing I would do is find my multiplication. I would do 0.01234 times 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the first part I would do. Okay, so they're giving that in scientific notation. Then I would take the the square root of that answer. Okay, and then I would multiply that by 2 times Do they have pi? They do. Pi times the answer. And then I would take that answer and take 1 divided by that answer. And I get 347,304. And we need 0.559 if you round it. And we need it to be in to the nearest 1,000. So we got 347,304.559. And then we would look to the right of here, so we're not going to round up. So 347,123 cycles per second. Okay. So that is it for lesson 7.1. I will see you back here for 7.2 momentarily.